Question number 10. The radius of a gold nucleus Z equal to 79 is about 7 into 10 to the power minus 15 meter. Assume that the positive charge is distributed uniformly throughout the nuclear volume. Find the strength of the electric field at part 1, the surface of the nucleus, and part 2, at the middle point of radius. Assume that the positive charge is uniformly distributed over the entire volume of the nucleus and does not come to the outer surface. Now, total charge inside the sphere Q equal to 79, here atomic number is 79, times protonic charge 1.6 into 10 to the power minus 19 coulomb, and radius is given as 7 into 10 to the power minus 15 meter. Now, electric field, either we can apply Gauss law or we can write directly E equal to Q divided by 4 pi epsilon naught R square. So if we put the values 79 into 1.6 into 10 to the power minus 19 into 9 into 10 to the power 9 divided by R square, that is 7 into 10 to the power minus 15 square. So we will get it as 2.32 into 10 to the power 20 Newton per coulomb, or this can be written as 2.32 into 10 to the power, sorry, calculation is little wrong, it is 23.2 into 10 power 20, or 2.32 into 10 to the power 21 Newton per coulomb. So this is answer to first part, means total charge. Now, second case, at the middle point of the radius, so halfway. So we have to find out what is charge contained. So we can say that volume 4 by 3 pi r cube contains charge q. Then unit volume will contain charge q upon 4 by 3 pi r cube. Then volume 4 by 3 pi r by 2, half of the radius q, will contain charge q into 4 by 3 pi r by 2 whole cube divided by 4 by 3 pi r cube. So this will give q by 8. So we can say q dash equal to q by 8. So 1/8 of this charge will be contained in the sphere when radius will be r by 2. So this sphere. So again, we have to find out the electric field. So electric field here on the surface. So it will be equal to, suppose it is E1 and charge becomes Q by 8, that is 1/8 of this value. So 79 by 8 times 1.6 into 10 to the power minus 19 coulomb. Now we can find the electric field by, this is charge times, we can put the value 9 into 10 to the power 9, which is value of 1/4 pi epsilon naught, and distance will be r square, that is this time r becomes r by 2, that this value will get halved, that will become 3.5 into 10 to the power minus 15 whole square. So the value that we get on simplification is 79 times 1.6 times 9 divided by, from here it will become 8 times 3.5 into 3.5 into 10 to the power, it will become minus 19 plus 9 plus 30. So minus 19 plus 9 plus 30. So on simplification, we will get 11.6 into 10 to the power 20 or 1.16 into 10 to the power 21 Newton per Coulomb, which is our answer. Consider next question. A charge Q is distributed uniformly within the material of a hollow sphere of inner and outer radii as R1 and R2. Find the electric field at a point P, a distance x away from the center, for R1 is less than x is less than R2. Draw a rough graph showing the electric field as a function of x for 0 is less than x is less than twice of R2. So here total charge is contained in volume 4 by 3 pi R2 cube minus 4 by 3 pi R1 cube. So we can write here total charge is Q, and this charge volume in which charge is distributed is 4 by 3 pi R2 cube minus R1 cube. Now, volume charge density. Rho equal to charge divided by volume. So Q divided by 4 by 3 pi R2 cube minus R1 cube. Now we consider a point P here. Suppose this distance from center is x. So charge contained, first of all, we have to find out the volume of that sphere. So volume, say it is V1, 4 by 3 pi x cube minus R1 cube. And charge contained, suppose this is Q1. So Q1 will be density, charge density times volume. So charge density is rho times volume is 4 by 3 pi x cube minus R1 cube. Now, we can apply Gauss law to find electric field, integration E ds cos theta. So here we are taking E ds along same line. So theta will be 0 degree equal to Q upon epsilon naught. So this will give ds means surface area of the sphere in consideration. So it will become E times 4 pi x square equal to Q upon epsilon naught, which gives E equals Q upon 4 pi epsilon naught x square. Now, we can put the value. So here Q means Q1. So E equal to Q1 is this rho times 4 by 3. Here Q means Q1, as I told you. So it will become a rho times 4 by 3 pi times x cube minus R1 cube divided by 4 pi epsilon naught 4 pi epsilon naught x square. So we can put the value of rho also. So rho is this much, this value. So we will get Q times 4 by 3 pi x cube minus R1 cube divided by, here we are putting the value of rho, so that is 4 by 3 pi R2 cube minus R1 cube. So we have put the value of rho as Q divided by 4 by 3 pi R2 cube minus R1 cube, then 4 by 3 pi then x cube minus r1 cube divided by here 4 pi epsilon naught x square. Now 4 by 3 pi will cancel out, and what we get will be E equals Q times x cube minus r1 cube divided by 4 pi epsilon naught x square times r2 cube minus r1 cube. So this is our final expression. Now we have to plot the graph. So as per question, in the region 0 to r1, there is no charge, and then charge is confined between r1, here this is r1 and this is r2. So charge is confined in this region. So here clearly the power of x in numerator is 3, whereas in power where it is 2 in denominator. So we can say that in the region from here to here, means from R1 to R2, electric field will be proportional to x, means as x increases, electric field will also increase. And after that, it will follow the inverse square law. So we can say for the reason R1 is less than x is less than R2, electric field E is proportional to x. So graph will look like this. Sorry, it will start from R1. So it will go like this. This point is R1 and this point corresponds to R2. And after that, for the reason R2 is less than x is less than 2R2, E will be proportional to 1 upon x square. So graph will look like this. Here E proportional to x, this is E inversely proportional to square of x. And this is our answer. Thank you for watching.